Okay, I think that's most people join now, so hello and welcome to this afternoon's webinar. So today we're looking at future livestock and new technologies. I'm your chair for today, Kirsten Williams. I'm a beef and sheep consultant with SAC Consulting, and this afternoon's webinar has been funded by the University Innovation Fund from the Scottish Funding Council. We've got a hashtag there in the middle of the screen, hashtag future livestock. We're going to try and keep going with Twitter this afternoon and put some posts up as we go along. So please, if you're doing any posting yourself, if you can try and use the hashtag future livestock, so we've got a bit of a trail. So we have got quite an action-packed afternoon. It is probably or arguably the nicest weather we've had all year, and we're sitting here with a webinar. So our absolute aim is to be finished for half past 3. So we've got quite a few short, sharp kind of topics to try and cover. I appreciate there's a huge amount of stuff in here. So please, if you've got any questions, if anything isn't covered just fully enough, please post them in the question and answer, and we will do our best to get to them. So livestock is the topic today. I know it's new technologies and there's many within agriculture, but livestock is a totally renewable natural resource that people absolutely rely on every day, be it wool for your carpet, protein in your beef, calcium in your milk. And there is many challenges face the sector. I wasn't going to start negatively and have every challenge here. It's just to kind of try and show that within every one of these challenges, new technology actually gives a really nice fit with them to try and help fight against the challenge. So kind of maybe have a think about your own business, the challenges that lie within there as we go through the speakers this afternoon, and just think what actually could really help your business and what might be quite useful or spark an idea to help you at all. I think new technology, quite a lot of people say that it's actually been quite a slow uptake within agriculture. I disagree a little bit with that, to be honest. I know EID came in, regulatory change that meant that we've pretty much had to do it, but some have really taken it on board, taken the technology and actually used it to measure and monitor performance and really, really aided their flock. 18 months ago, none of us would have known what Zoom was, and here we're all in a Zoom meeting today. Now we can trade livestock. There's trading platforms like Sell My Livestock. All auction houses are doing online auctions, and that's us using technology. Dairies have got robots, beef farms have got calving sensors. There's loads and loads of different technologies out there. It's just knowing what there is that suits your system. And they really let you actually manage animals per animal rather than as a group. So rather than that field over there, all lambs need to be wormed. It's actually look at their, measure their performance, monitor what they're doing, and it really does help save money, helps efficiency and your technical performance, which all helps with lowering your carbon footprint. So there's loads to think about today as we're listening to our speakers. Two things I just want to highlight, things that are out there. We've got SRUC Bytes is available. There's 8 films. They're in depth. There's about 20 to 30 minutes. They're looking at interviews with farmers, industry professionals, looking at different tech. First one is distributed ledger technology. So that's like blockchain. There's other things there, drones, you've got robots. There's a really, really good resource there. And you can see that the link is there for them, which I can put into the chat for you all. We've also got Farming for a Better Climate. Again, a massive, massive resource, totally free, totally available for everybody. Click on the website, which I can put into the chat bar again. And that's really, it's got podcasts, it's got case studies, it's got fact sheets, and it's all looking at ways that you can reduce your impact on climate change. So have a look at that as well. Finally, we're on Zoom today. So I'm sure everybody knows how to operate Zoom now. There's a Q&A panel there. So if you've got any questions, no question is a silly question, please post them on there. We'll do our best to try and address all questions. Any we don't get to, we'll follow up with an answer after the webinar today. So we've got a pretty tight agenda. So I'm going to hand over to Stephen Thomson, who's going to talk us through understanding the power of data. I'm going to, just while I introduce him, I'll let Stevie get his presentation up. So he is a senior agricultural economist with a huge amount of experience within the agricultural and rural policy analysis. So he's involved in a huge amount of projects, a lot of policy driven projects, and data is a key part. So he is very, very well suited to give us a rundown of understanding the power of data. Stephen.
Thanks very much, everybody, and welcome. I'm asked to give a bit of a whiz through the understanding the power of data. And I suppose it's like my policy perspective quite often, but the more you get into the drivers of change with regards to agricultural practices, the more you realise that market, consumers, and policy are all after roughly the same things now, and data is a must going forward. And the reason I have this little thing, this little booklet, look back, you're not going that way. And I would add in, the future's not what it used to be, is because we are evolving, and we're evolving processes at quite a rapid rate. And I suppose the key thing, and Kirsten's mentioned it, is climate change is one of the key drivers now. It's a key driver for policy, but it's also a key driver for your consumer, for your banking sector, etc. So the banking sector is decarbonising lending. So unless you're on that trajectory yourself, then the chances are in 5 to 10 years time, then you will get disadvantaged in terms of your lending rates if you can get lending. So everybody is coalescing around net zero and decarbonisation, but equally there are increasing challenges with regards to biodiversity. The UK government are talking about setting targets for biodiversity improvement. Scottish government have mentioned these things. So that means then that there's going to be these real policy and market force disruptions that are occurring. And whenever you've got disruption, it allows for opportunities to try and do things differently. Technology allows us to do these things differently, or do things better, or look at things in a more nuanced lens. And one of the key things that wherever you look at climate change, and you can see the reduction profile for Scottish agriculture and land use change in forestry, it's a bit of a mouthful, but those are the two things that really impact on agriculture in Scotland. You can see their profile changes with regards to Scottish Government targets, going from 18% of emissions to 42% Scottish emissions, should all the other sectors achieve. And behind all of that, technical efficiency and carbon footprinting are going to be an absolute vital component of your sort of daily, weekly, monthly lives. And I suppose I was really taken by Robert Ramsey's statement when I was, it's something I'd found a while ago, and I thought, gee whiz, that just nails it. Where he said, if you don't use data, you're guessing. And with businesses now being more competitive than ever, there's no space for bad decisions. If you want to make a real decision, you need to base it on data. And it rings true. And the agricultural champions back in 2017-18, when they came up with their report, also talked about the importance of data, and that policy decision must be based on evidence. Evidence comes from data. And it's not just the case that we need to get farmers or land managers to collect that data. It's actually use that data and impact and then make changes based on that data. So it's all about providing an evidence base, and actually providing an evidence base that you can make future decisions on that impact on your profitability and what you're delivering on environment, on carbon, etc. So data is king in this sense. And just giving you an example, you all have to do official things such as register calves and movements of cattle. And then recently we've been looking at the CTS data and actually assessing across businesses how performance looks at key metrics. So we can actually take this official data that nobody really uses for metrics and performance, and actually start better understanding what happens at a farm level. Or you could do it at holding level, and indeed you do it at an animal level in order to aggregate up. And it gives you an indication of where the wins could be, well, are the easy wins. None of them are easy wins, where gains can be made in terms of the technical efficiency. So the graph on the graph on the left is just the sort of calf registration rate per 100 breeding cows. It excludes heifers because heifers are difficult to deal with, but it shows the variation that you've got within the systems. So there's 25% of the industry above the upper quartile, 25% of the industry are below the lower quartile. And you can see there the lowland sucklers, 75%, so 75 calves registered per 100 breeding cows. And then the graph here with the grey is showing the mortality rates. And this is the calf mortality rate, so under 36 months, animals under 36 months is what we've used here. And you can see there's sort of 25% are above that 75, that 7.5–8% threshold. So that's calves dead. A calf dead is basically wasted resources, and yet there's 25% of the industry are sitting below 1.75% mortality. So it gives you a real indication as to where improvements can be made. And we're currently working with HDB on a benchmarking tool, so farmers can go in and investigate their own data, compare with others, and see, perhaps drill down to see where they're actually being inefficient, perhaps. And the more you think about it, the more integrated data is going to become. So this is a bit of a messy diagram. It's not mine, but it summed up the need for data and monitoring absolutely. So governments, this box down here, I've got markets and policy. The original authors just talked about policy, but both markets and policy can set and incentivize mitigation, so carbon mitigation targets or biodiversity improvements. So they can actually start signaling to the farming industry. Now, if it's through policy, which likely is coming, that will be in the guise of technical efficiency measures. And then working with researchers who help policy understand this, it's about providing opportunities and choices to farmers. Now, nobody can force you to do anything, but if you're incentivized to do things in a different way, or to attain or try and attain the top level, then you could, under future policy, get a higher level of support than those that have got less attainment. So those that are less efficient and those that are delivering less for the environment perhaps will be not penalized, but they won't see the payment rates that those that are delivering get. And within all of this, if farmers are doing that and getting paid on performance, in monitoring and evaluation and validation of what you're achieving on the farm becomes absolutely vital. And that means data. So absolutely understanding what is happening in the biological and the sort of market forces element on your farm. So I hear quite a lot in the farmer-led groups about soil sequestration, carbon sequestration. Yeah, I keep saying, well, have we got proof of that? And there is research proof, but we don't have the living labs that are farms. And then all the way along the supply chain, this whole idea, because people think about waste on farms in terms of dead animals or in non-productive animals, but actually quite a lot of the wastage occurs in the supply chain beyond the farm gate. So again, there is ways that government can signal to make improvements there, and also to signal behavioral change within the consumer, so that then the whole supply chain can be impacted by policy and market levers. And behind all of that is data. And this is where this term blockchain comes in, which is this validation process throughout the entire supply chain, from production all the way through to consumption, where where blockchain is actually providing those guarantees. So data-driven can help you meet your market and policy needs. And if you start thinking about where data has actually helped make improvements or can help make improvements, you don't need to go much further than the BVD eradication scheme. Incredibly data driven. So sampling, testing, monitoring, all of that's been data driven. Carbon sequestration, as I mentioned previously, are you actually doing it? We need actually systematic field level and farm level data collection to actually try and prove or disprove the science base on carbon sequestration, because currently there are models out there that say what that carbon sequestration are, but it should and likely is unique to each farm. So if we start a process of data collection, then we can better actually inform government, who then can help researchers and government models change into more reality. Again, biodiversity, the farmer-led groups, there's been a lot of discussion about how do farmers better engage or prove that they're delivering on biodiversity. And Nature Scott are developing an app, a smartphone app that allows you to take pictures and submit them as proof that you're actually making delivery. These are geotagged photographs that actually have a timestamp and a GPS location that actually show when and where that photo was taken, that you can then submit as evidence. If you've got consultants coming in, KE and that consultancy advice, it's only as good as the data that you can provide them. So the more data that you can provide experts to help you on your business, then the better that advice can be and more tailored to your actual needs. And again, in all of the policy discussion, there's been discussions, there's been a lot of call for more one-to-one advice and bespoke advice tailored to farmers' needs. And you know, in the Suckler Beef Climate Group, there was a lot of discussion about the need to actually have that one-to-one advice to help the industry through that process. And then carbon footprinting, I think it goes beyond carbon footprinting in that the consumer is becoming a pretty savvy person, and the power of retail, because of the consumers, mean that processors, the retailers, are demanding more and more knowledge that is about you and processes, and that data is on carbon, on use of antibiotics, on chemicals, etc. And the more trade deals, the free trade agreements that we enter into, if we are doing exports, say into Japan, then they've got different set of standards as to what chemicals can be used, what processes can be used, and what labeling requirements there are. So that then may mean that there is an additional requirement if you are if your product is going for export, to supply that data. So actually having that data in a ready to use format will be vital. With regards to policy, if you've read any of the farm-led group stuff, they all talk about the need to baseline, that we don't actually have a robust baseline on farms just now. And quite a lot of the discussion was about soil analysis for carbon, not just pH, silage and slurry analysis for livestock farm, carbon audits, biodiversity audits, animal health plans, nutrient management plans. And it seems that, you know, when you start looking at it, like from a snapshot in time, that seems like an awful lot of additional effort on the part of the farmer. But if you phase that in over a period of years, then actually you can build up this evidence base. It doesn't all need to be done on day one. And if both the arable and dairy farmer-led groups kind of came to this sort of concept of a carbon smart farm plan, where you actually are looking and creating a plan as to how to reduce your emissions. Now, the farm itself can use all this data to improve technical efficiency, improve their environmental accounts. Most of that will improve your profitability. It may help you access banks, sort of lending, overdraft facilities in the future. As I said, they could be tied to that. All of this data can also then help the government monitor and verify performance. They've got legal targets that they've now got to achieve, and they need you to help. They need farmers to achieve those targets. And then the key thing for this going forward is actually, will they use this data to actually pay you? Now, the ELMS approach in England, the DEFRA approach, is about meeting certain standards across a various different set of things. I don't think there'll be much difference in Scotland. Just how we deliver it may be different. So we are again looking at tiered payments based on what you are actually achieving. So if you're in the top echelons of calving percentage, you're at 95%, you'll be at the top end of the tiered payment, providing all of your other tricks get there. As I say, the processors, retailers, exporters, consumers, buyers, there's an awful lot of people with an interest in your data. Some of it from a policy perspective, some of it from a market-driven perspective. And if the market demands it, then it's hard for you to say no to providing that data. Data opportunities, I'm not going to go into any of these details in any real detail other than because other speakers are going to talk about that. This piece of work, this is a thing that's just come out from DEFRA a couple of days ago on enabling genome enhanced precision farming by building traceability. And of course, if you think on, Kirsten mentioned sheep EID, and how we've managed to, or some farmers have managed to use that technology to embed better management principles, better monitoring on the farm of individual animals, and bovine EID is likely to have significant benefits on that as well. Particularly if you start looking at the opportunities that Scott EIDs, UHF, ultra high frequency tags can bring, because they allow you to write management information onto the tag as well as pull information off it. And if we went down this route, we could get rid of the bureaucracy of paper passports if the passport sits on the tag. Things like digital sensors, so smart rural digital sensors. I mean, it's amazing how quickly these sensors are all being developed, that you can low tech, it says relatively low tech or low cost sensors that allow you to start monitoring so many different things. So soil and soil temperature and moisture, electric fence battery monitors, river level monitors. Yeah, it's an endless set of opportunities for us to actually pull data from your farm remotely and actually better understand and actually set warning bells if something's happening. And then blockchain. So Food Standards Agency in England are already using blockchain in the slaughterhouses to provide that entire traceability system. Northern Ireland are starting to use blockchain to prove the provenance of their animals in an international market and in national markets to consumers. So there's a huge set of opportunities here for the industry, and data will be king as we move forward. I think I've spoken long enough, Kirsten, and hopefully haven't run too far over time.
Perfect. Thank you, Stevie. There is one question. It's a massive question, so I'm going to give you 2 minutes to answer it while Malcolm puts his screen on, and that is, how would a policy
there's two questions.
There's two. I'm going to give you one though. How would a policy based on payment for improved efficiency affect their attempt to keep within WTO green box?
Hi, Brian. So this is the quandary that I think everybody's been trying to have. So ELMS is probably struggling with this a bit more than we are just now, because they're going down this route of environmental payments. So it's explicitly a payment, an agri-environment payment, which then comes with, as you quite rightly say, income foregone additional cost, which cannot build in a profit level. I've heard both DEFRA officials and Welsh Government who are going down a very similar route, saying they're just going to add elements onto that. Now, that might come with WTO issues and also trade. So we're in all these FTAs, people might complain. In Germany, the officials there are saying that they don't see how it can happen. So they're moving to coupled payments with conditions. And in Scotland, the model that we've been proposing to government and to industry is that you keep the direct support element, but you have different tiers of conditionality. We already have that. So we have it with our greening payments, whatever they may have meant to people, very little in some situations, but also in cross compliance. So if you fail on them, you get a scale back. So you can build it into a direct income support measure, relatively straightforward. I think that currently would be WTO compliant in terms of getting to that enhanced performance. And beyond that, you would go into actual targeted agri-environment, such as we've currently got with EECS or forestry schemes, or indeed peatland restoration. Hopefully that's asked you
Super.
answered that, Brian.
There's a few other questions there as well, but we'll maybe just try and keep ourselves on time and either come back to them or we can get an answer specifically for you. So moving on now, we've got Malcolm MacDonald up next. So he's an agricultural consultant based in our Inverness office, and he is holds a really, really varied role, to be honest. And he's been working on a project over the last year on virtual fencing. So Malcolm, I'll hand over to you.
Okay, thank you, Kirsten. Yeah, I'll just give you an overview of a risk group I was involved with and virtual fencing. So I'll just, first slide will just be, if it'll come up. Just give you, make sure everybody knows what virtual fencing is, because you may have heard the term bandied about, but the fundamentals of it are that you've got a collar on a cow or a sheep or a goat or any grazing animal, and the collar is linked back to GPS initially to say where it is all the time, and then also some kind of data, transfer to communicate back to a computer or smartphone. And essentially, your cow's got the collar on, and as you see in the diagram, they've got a virtual fence line which they can approach, and as they approach, they'll get some kind of negative stimuli from the collar, initially a sound, and then usually an electric pulse to deter them. So essentially, you've got a fence line which there's nothing on the ground, but the cow should respond to it. That's the basic fundamentals of it. The idea has been around for quite a long time, even as far back as the 1970s, I think. But getting the technology to catch up with the idea was the challenge. You may have heard of some of the buried cable methods. They've been kind of, in a limited sense, on the go for a few years now. But they're quite limited because you do have to bury your cable, which is expensive, and it only works for a set amount of distance anyway. So we're now getting to a stage where there is collars available, which will do this remotely with GPS. Thought I'd show you virtual fencing from the software side before I go into any more detail. This is a no fence software. This is just showing what you'd see as a user when you're setting up a paddock or a field. Essentially, you can map around the boundary with so many points. You can make any shape you want up to a point, but for the sake of the livestock, it's better to keep it a fairly simple shape so they can't get trapped in corners or confused. And the also quite useful thing is that you can exclude areas within the field as well. This is from SRUC's Kirsten farm, where they've got a field which borders onto West Highland Way on one side, and that's a novel use of the technology to keep them away from that. So I facilitated this risk group to look into virtual fencing. I facilitated it, and I worked with Tony Waterhouse on the research side, also from SRUC Kirsten, and he used his kind of research contacts to make contact with these companies who have got virtual fencing collars. I'd had a few phone calls over the kind of last few years from clients and people in the area who were interested in the technology and were keen to be involved in any trials SRUC might have done. And we had done trials in the past, but there was nothing current at that time. And at that stage, I didn't know where the technology was, if there was going to be anything available, or if it's still a while off. So when I saw the opportunity for the funding, I thought I'd use that to pull a group together and get Tony involved to see if we could get some virtual fencing collars on farm in Scotland, which was the kind of main aim. We had 7 farmers and crofters in the group, fairly diverse situations, some of them with large open hills, some of them more kind of upland rather than hill settings. So quite a few different kind of options or scopes to use this kind of technology in. We started in late 2019. We had our first and only in-person meeting in December 2019, where Tony came up to the Inverness area and spoke to the group and kind of gave an update on the kind of the state of technology and what he knew about it and where he thought there might be technology available. And it was just around this time Tony made contact with the Norwegian company No Fence, who were at that point launching, or they just recently launched, kind of commercially available virtual fencing collars in Norway. And they were quite keen to kind of, get a few collars into UK, and we kind of had the ideal kind of early buyers or test group available to them. The original plan was that we'd get a handful of collars over to use at SRUC's farm, and that would give the group a chance to see them working and then make a decision on buying. But due to COVID and initially manufacturing delays back in early 2020, a long story short, it was delayed and that wasn't possible. But the farmers did decide to buy some collars themselves, and we had collars on farm by September 2020. This is just a picture really showing the collars on the cows, on one of the farmers' cows there out on the hill as well. As you can see, they're quite robust units. They are, you know, they're quite robust. You can see on the side there's a solar panel which is part of it, which is topping up the battery all the time, and then you've got the chain there is what the electric pulse is delivered through, and yeah, they're fairly tight in the neck. They need to be reasonably tight so they don't swing about and annoy the cows. And the wee green thing at the bottom, that's where the battery comes in and out too. So yeah, they're quite chunky and they're quite heavy in your hand, but they are fairly robust for being outside, which is what we want. And again, this is the title picture on my slide. I would say that the group was titled Virtual Fencing and Real-Time Tracking Hill Cows. My initial thought that the best place, or the place where this would be most useful, is in extensive hill settings where it's difficult to do traditional fencing because of, you know, long areas and difficult terrain, which I think is true to some extent. Maybe coming out of the group, it's got more application on low ground settings than I expected, or I at first imagined. But that was the title of the group, and that's what we kind of focused on to some extent. The kind of conclusions from the group, or the thoughts, we didn't do any specific trials on the farms. It was just a case of really putting the collars on the cows and seeing how they get on and using them as you know, you would use them commercially. They do work very well. The cows, they get used to the virtual fence, they get used to the collars, and they really do respect it. They don't break the virtual fence very often at all, and that's only usually when they're getting used to it anyway. You do have to have a few days, maybe up to a week kind of adjustment time initially with the collars on, but not switched on at all, just so they get used to having something around their neck. And then after that, you have to keep them in a relatively small field as a kind of training area so they can approach the virtual fence slowly and get used to it. But once you've had that kind of maybe a week, 10 days or 2 weeks kind of getting used to it, they really do respond well to it. They don't break out very often. We had I think speaking to farmers, maybe 2 or 3 cases of cows breaking out, and you do get an alert on your phone when the cow breaks out, which is very useful. But in most of those cases, the cows had actually gone back in by the time that they went to check. And if they do go through the virtual fence one way, they don't keep on getting electric pulse or the noise. It just stops and they can kind of calm down. And then when they come back through the fence from the other direction, they can just walk back through, but then they turn around again and the virtual fence is there. So it works like a one-way gate, which is a lot more useful or better than even any physical fence would be in that respect. Battery life was quite a serious concern when we're looking in the early days when the group was looking at the collars. Didn't want to be replacing batteries 2 or 3 times in the grazing season. That would make it, well, it would be potentially less attractive anyway. But battery life looks very good. The solar panels work quite well at topping them up very well, I'd say. Speaking to a farmer last week, and he said that his collars right now are sitting at 100%. With the nice long summer days, they're getting enough sunlight just to be fully self-maintaining. And the collars last year, when some of them went on in September or even later, of course, that was shorter winter days, but a lot of the collars still came off the cows in December, even with maybe 20% or 30% left in them. The battery life obviously depends on how often the cows are testing the fence and getting the music played to them. That drains it. And also, if they're not getting good data reception, then the more they're looking for data, the more they burn the battery too. So if the battery is draining, there's usually a reason for it. But when they're working well, they seem to be quite good. One farm did have a bit of bother with getting the right data reception, because the collars, they've got GPS all the time. That's fairly easy to maintain, but making sure you've got a mobile phone data reception can be a bit more challenging. The 2020 collars that the farmers had, they ran off a 2G mobile data connection, which is fine. It's fine. It's enough data to maintain the field boundaries and all that. But we don't always get the best reception for that in some areas. However, from 2021, they are going to be, or they say they're going to be receiving 4G connection as well, which should help that aspect of it. Yeah, the no fence collars, they've all essentially got like a SIM card or something like a SIM card in them, like on your mobile phone. So each one of them is an independent unit, which is, getting a data connection. So that in some areas that could potentially be a challenge to them working well. However, even when they don't have data, the virtual field still sits there. That's still fine. Like even if you don't have a data connection, they will still work. It's just you won't get an update on where the cows are. You won't get a text if they break out because it's not sending back to your phone or your computer. So they don't work as well, but the cows still won't necessarily break out even then. And collars falling off. A handful of collars did fall off or get knocked off by the cows, just kind of either scratching against trees or somehow getting them off. Generally, it's not too much of a problem because they've all got a GPS receiver in them. You can just go and find the collar. That's not too much of a problem, but it does happen. It's something to be aware of. Kind of thoughts and lessons. The cost, the no fence collars. I would say No Fence is a company which we kind of went with or made contact with because they are the only ones who had any collars which would be available in the UK. Tony did make contact with some of the other companies, but they seem to be a bit off kind of commercial release, I would say. But I'll talk about that in a minute. Yeah, so the No Fence collars cost about kind of £250 to buy up front, and then a kind of £40 to £50 subscription. There or thereabouts. There's no secret to the cost. If you go on the No Fence website, it will tell you all these things. You can put in a quote calculator. So my gut feeling, I think the farmer's gut feeling too, is that's still a bit expensive, especially on a purely commercial basis. A few unknowns, like say lifetime of the collars. If the collars last 10 years, that looks fairly cheap capital cost. But if they only last a couple of seasons or 3 or 4 seasons, that is quite expensive. But again, I mean, they are very robust, so there's no reason why they wouldn't last that long, but it's just something to be aware of. We had a couple of the group members had very little kind of fencing and infrastructure in place, and I think the collars were more attractive to them, obviously, because they would be looking at spending potentially thousands or tens of thousands of pounds on fencing to get a similar result. And for them, the collars, certainly feel like good money, or better money, I would say. So in these situations, I think it's very useful. And conservation grazing as well. I think right now at that kind of money, that's the other area where you'll see the collars getting better uptake, is where there's something more than just commercial incentive to use them. Just kind of future and potential uses. Rotational grazing. I was hoping if we'd got a full grazing season last year of them in use, we would hopefully seen this dried out. I think that's a real potential, is rotational grazing. That's a real way to increase your pasture output and pay for the collars. As in, instead of using lots of electric fencing, you've got your collars to do it too, and you should be able to do it in a matter of minutes on your phone instead of having to roll up reels and stuff like that. And the other aspect, virtual herding or gathering, using the collars to pull cows into another field or even into a handling facility. If you can kind of, automate elements of that, that'll be another way to really, make them make money. I don't see why that can't be done. I'd like to see it done and see how it goes. Maybe the cows wouldn't react too well to the fence moving too often, but I think once they're used to it, it would be fine. Heat detection and monitoring would be another kind of potential benefit. The no fence collars don't do that right now, but it's something I think they're thinking about. And the collars do have a pedometer in them and the GPS. I don't see any reason why they couldn't be quickly made into a reasonable heat detection kind of tool. And grant funding. I think the SACG grant last year, I don't see why in any future scheme like that, the collars like these couldn't be eligible for funding, because there's a very easy argument that they increase efficiency and all that type of thing. And I've mentioned environmental schemes there too. A lot of you'll know that there's a lot of fencing is paid for out of environmental schemes to help manage areas through the schemes. Using some of that budget to pay for maybe collars, especially on moorlands and stuff like that, I think would be quite good value for Scottish Government or any other government. But that's something else to think about. And as time goes on, the cost should reduce as we get more companies on the market. and I'll give you a quick overview because I'm aware of time. There is it's kind of 4 companies which have got collars near the market. No Fence, as I'm aware, No Fence are the only ones who are commercially selling them. But eShepherd is an Australian company which is also very close to commercial release. I think Tony did speak to them, but they didn't have anything ready for trialing or release, but it's almost there. Vence is a US company, which seems to be in kind of late or pre-commercial trials, so they should be pretty close to market as well. And Halter is a New Zealand company, which is focusing more on the dairy market and looks to be a very comprehensive health monitoring, virtual fencing, and potentially virtual herding package as well. But it'll likely be quite expensive considering it's on the dairy market side of things. But that's about it from me. Those are my conclusions. I think I've covered most of them. The main takeaway was that the collars do work really quite well as they were sold, and the cows really respond quite well to it. But I'll leave it at that.
Thank you, Malcolm. There is a power of questions have come in. So I'm going to give you one that's going to kind of tick off 2, and then I'll maybe just ask you to type an answer to all the people to get an answer out there. But there's 2 around horned cattle, so we'll maybe go with that. And what's the risk of collars getting caught in vegetation or causing issues with horned cattle getting horns stuck?
I'm not aware of any trials being done with horned cattle. I mean, as long as they're fairly tight to the neck, I don't think it would be an issue. I'm pretty sure there is some kind of release mechanism that if they're pulled with enough force, they will just break off. I think that they shouldn't be possible that cow will be able to like strangle itself on the collars or anything. They will break before that would happen anyway. Yeah, the collars, horned cattle could be a problem, but I think the collars have to be fairly tight, so it would be very difficult fairly difficult for a cow to manage to hook a horn underneath, another cow. But yeah, I can't say I haven't seen any. I haven't seen them used on horned cows yet. There's something to think about.
Okay, thank you, Malcolm. Loads to think about there, and it's fantastic to see it actually happening in Scotland when we hear so much about virtual fencing, to actually see it working in practice. So thank you for that. Next up, we've got Neil. So Neil, I'll just let you get your screen up for a minute. Neil is a livestock geneticist, and he has got a particular interest in new technologies and the applications in measuring and quantifying how to measure traits. He's actually now the head of new business development in SRUC, but he does keep a keen interest in technology and breeding developments, especially related to carcass and meat eating quality. So Neil, I'm going to hand over to you to present.
Thanks, Kirsten. Thank you. I'm sure everyone can see my screen okay? Yeah.
Yeah.
Yeah, okay, thank you. Well, good afternoon, everyone. And thanks, Kirsten, for the opportunity to talk a little bit about measuring or assessing meat quality, and present some of the previous work that I've been involved in and that's been undertaken in this area, and also some of the new technologies that are being applied in this area. Obviously, as always with these things, there's a bunch of people that input into this work, and some of them are listed on this slide here. So Nicola, Kirsty, John, Joanne, or Joe, and Luke's previous colleagues. There we are. So, as always, I kind of start off these sort of talks by sort of framing what we mean by quality or meat quality, and really meat quality is a combination of a number of related attributes. So it's influenced by a multitude of biological and environmental factors, and because of that, the definition and understanding of meat quality, if you like, is complex, and it considers lots of different attributes. I'll narrow that down as I talk, but it's important to understand and define what's meant by quality, and then what aspects we can and can't measure or manage. And I like to sort of think about it in 2 main categories. So I present it in this way, that the first category is that there are intrinsic factors. So these are factors related to the animal. So we could put in there killing out percentage, lean meat yield, grading of carcasses, appearance at point of purchase, colour, flavour, juiciness, etc. And then we've also got extrinsic factors. So these are quality factors that can feed into that, which are factors, let's say, linked to the production cycle. So stuff like price, brand, experience and preference, quality assurance schemes, country of origin, welfare status, etc. So these are the two main sort of categories. And across those main categories, quality really means different things to different people involved in the production cycle. So it makes it a little bit more complex. And these intrinsic and extrinsic factors are variable in importance or perception across the supply chain and the production cycle, and indeed within the supply chain. So quality means it is satisfied in different ways across this production cycle. So the producer, the processor, and often the retailers are satisfied through commercially relevant and measurable quality or efficiency parameters such as killing out percentage grade, lean meat yield, back fat, thickness, etc. And the retailers sort of overlap obviously into the consumer market, and so the consumers are satisfied by different parameters at point of purchase. So appearance, texture, flavour, juiciness, wholesomeness, and increasingly now the health benefits or not of these foodstuffs and proteins. And I'm not going to touch on it at all, but we obviously can't ignore the fact that currently spotlight's on animal protein regarding the environmental credentials of production. So I'm not going to touch on that at all, but you might hear a little bit about that later on in some other talks. So yeah, so through that production cycle, the quality is satisfied in different ways. So it's not a simple thing just to say, quality is one thing or the other, but it's relevant across the whole production cycle. So really, most of the work that I'm involved in is concerned with developing more consistent meat quality, meat eating quality, and in order to achieve this, we can approach it in three main areas. So one is developing non-invasive, so proxy measures of quality that can be taken on the farm, in the live animal, and or at processing. And what I mean by quality in this respect is meat eating quality. So those organoleptic traits, and the second place is genetic, applying these proxy traits in genetic and genomic evaluations that allows for selection for meat eating quality, or for the proxy trait of meat eating quality. And then of course there's management protocols on farm that can maximise that product quality. Now I'll be concentrating, or my work concentrates, or our work concentrates on these two main areas. So those development of those non-invasive proxy measures, and then the implementation of those proxy measures into genetic evaluations that can allow for selection for these traits. So back to the most sort of relevant traits for the consumer and how we might measure and assess these. The most relatable concept is the measurement of organoleptic traits. So these are the traits registered with our senses at point of consumption. And currently, the sort of gold standard here is performed through taste panel assessment, either a fully trained taste panel, semi-trained taste panel, or consumer panels. And these sort of assessments are very expensive. It's a very slow process, and in order to sort of implement these things into breeding programs, etc., the tests need to be routine and of sufficient quantity. So back to what Stevie was talking about, data richness is important. So these sorts of issues are limiting the inclusion of organoleptic traits into of meat quality into current breeding programs in the UK. So as we sort of progress through this, I'll talk about how we then sort of relate. So the proxy measures are what we are relating to these sort of organoleptic traits. So the gold standard is always going back to these consumer trained taste panels, etc. So this is just an example of a taste panel, and this is SRUC's mobile sensory lab. And here you can see, so that's a very expensive piece of kit, but you can see a panel of consumers who in this instance are testing some poultry meat. And then down in the bottom left here is the sort of sample preparation area. So it can also be repurposed as a lab space, but that's basically where all the samples are cooked and prepped to then be served out to the consumer taste panel. And part of this process includes kind of standardizing the environment, if you like, that the consumer's in. So in the middle here, there's a booth which the consumer or a taste panelist or whatever would sit in, and there is there's sort of environmental controls there. So there's constant recirculation of air through there. There's an iPad or a tablet which they can input their preferences in, and then along the bottom right here, what you can see is the different lighting systems that we can use while we're testing these meat samples on the consumers or the trained taste panel. So there's a red light to standardise any sort of visual aspects of the meat if we're not asking any questions about visual appearance, or so that it doesn't influence the objectiveness of the panelists. And then we've got two different sort of natural lighting systems. So sort of yellow light, which is more like an indoor light, and then we have like a sort of blue hued light, which is as close as we can get to daylight with an artificial lighting system. So that's just an example of a setup for a trained taste panel. And normally up at the other end of that mobile lab, you saw the lab space. What we normally do often alongside these is that we would routinely perform what I call first stage meat quality analysis. So these are objective meat quality measures that are well used and well documented, and they're known to have an effect on or known to be able to or related to organoleptic traits. So these sort of broadly are pH, so measurements of pH, measurement of mechanical tenderness. So there's 3 different measures here: rapid slice shear force, Warner-Blatzler method, or Mirren's, and that's generally different across different protein or species, so lamb, beef, pork, etc. And then we've got objective colour. So sorry, I should show you this. So this is the rapid slice or mechanical tenderness machine, the Teagasc. And then we've got objective colour here, which is a basic measurement of reflectance or colour spectra on a meat sample, a fresh cut meat sample. And then we've got what we use is near infrared fat analysis. So that's a sort of laboratory fat, protein and moisture analysis of those samples. And here's an example of that type of work in action. So this is a meat lab that we've got at SRUC, which is working currently on some beef samples, and they're using routine testing of this first stage meat quality. So they've got visual scoring of the marbling of the beef samples, and also some use of the new technologies that I'll talk about. And then you can see the force food scanner there. So they're going through the whole process there, minus at the moment the taste panel. So we're collecting data over, I think it's 6,000 samples or something routinely through this lab. So I'll talk a little bit about one of the measures, meat quality measures that I suppose we use, the objective measures that's most relatable is mechanical shear force or mechanical tenderness. And like I said before, there's really 3 different methods that can be employed for different meat categories. But what you see here in this slide is a beef sample, and we're using rapid slice shear force. So basically the samples are cooked to a specific protocol, and we can, depending on the method, take 1 to 10 samples across the protein sample. And then after the meat's cooked, it's prepared. So in this image here, you can see there's a slice taken at a 45-degree angle, so we're shearing across the muscle fibers, so it standardizes the sample preparation. And then the cooked meat is basically compressed between the metal, the blade or the metal tooth or jaw. And then on the left here, you can see a graph of what we record as the peak force required to compress this meat sample. And we take that as peak force. And this is very commonly used as an objective measure of tenderness or toughness. So you'll have noted that many of the previous objective measures I've touched on are destructive, or at least require sample preparation prior to measurement. So our previous work was related to a couple of things, and where my main interest lies is the relationship of intramuscular fat, so marbling, with eating quality. And this is a known and well-proven relationship that intramuscular fat has a positive effect on eating quality. And knowing that relationship, of course, we wanted to develop non-invasive, non-destructive measures or proxy measures of meat quality. So my main interest is in the measurement of intramuscular fat. So to put that relationship to eating quality and intramuscular fat into context, and most of my work is in lamb as well, I should say that. There are a few studies that can be drawn from, and granted they go back to '88, but they're all still very relevant. So Saville, Cross, and Halen here reported that acceptable eating quality was related to 2 to 3% intramuscular fat in red meat and lamb. Hopkins reported that greater than 5% intramuscular fat was related to better than everyday eating quality in lamb. And then through some of our work at SRUC, a lot of this work's done in New Zealand and Australia. Through some of our work at SRUC, we identified a sort of window of acceptability in some of the studies from a UK trained taste panel in lamb, and that found that the sort of window of acceptability was 4 to 5%, but could tolerate certainly, just over 3%, so 3 to 4%. And just to put that into perspective, these are kind of 2018 data that's drawn from. These are some mean intramuscular fat levels in CT scanned slaughter lambs, included in various SRUC trials. And you can see the average intramuscular fat across these slaughter lambs are certainly below those sorts of preference levels. So we've got Texel Cross Mule and Scottish Blackface ranging from 1.4 to 2.3% intramuscular fat. Just checking my time. So intramuscular fat estimates provide an opportunity and are of interest as an objective proxy for meat eating quality. And as I previously mentioned, measurements of intramuscular fat were limited to laboratory methods. So a technology that's applicable to this, and I'm sure you hear about more in some following talks, is computed tomography. So CT scanning, through a lot of previous work of mine, has proven that it can provide very accurate estimates of intramuscular fat. So greater than 65% accuracy 65% accuracy in estimating chemical intramuscular fat using CT scanning. So just a quick sort of brief introduction how that works. Live animals are CT scanned and the images are dissected to remove the non-carcass elements. You can see the whole carcass scan, spiral scan here, rotating through. And then, this is still a live animal, but the internal organs have been removed. So the parts of the image that are left are representative of the carcass, if you like. And then pixels in these images are then allocated to fat, muscle, and bone according to the density thresholds that you can see on the right side here. And from this, we can determine a number of traits related to carcass and meat quality. So I'll show you about that later on. But most recently, we've been able to predict, assess, or measure, if you like, intramuscular fat. And these traits this novel traits now included in terminal sire sheep breeding programs, allowing for selection of IMF and an index alongside other things. So just to sort of put that in context, I suppose here's a plot of close to 2,000 CT scan terminal sires. And this lets us see both the relationship between carcass fat and intramuscular fat. So carcass fat's along the bottom here on the x-axis, and intramuscular fat's on the y-axis. And normally what would happen is there's selection for reduced carcass fatness in these animals. So we would generally see selection across the whole left side of this graph. But the inclusion of CT intramuscular fat in these breeding programs allows us to select for what I'm calling these correlation breakers. So these are animals that have high levels of intramuscular fat, higher levels of intramuscular fat, but still maintain lower levels of carcass fat, so satisfying both the processor's requirement for leaner carcasses while maintaining eating quality or intramuscular fat levels. Some of the other technologies that are being investigated are in advanced imaging, if you like. So two of these, which we have the capability for at SRUC, are visible to near infrared reflectance spectroscopy, or VIS-NIR, and hyperspectral imaging. On the bottom left is the hyperspectral set up with a beef sample, and both in the middle and the far right is visible near infrared set up with beef and lamb samples respectively. And just to give you a bit of background about that, the visible to near infrared method collects information as a result from chemical bonds absorbing or reflecting light in different wavelengths. So this one it's important to define that it's measured at a single point through this light gun on the left-hand side on the bottom of the slide, and then the resulting data shown on the right there, which is the levels of reflectance or absorbance across those wavelengths of light, or the spectrum of light. So this type of technology is highly developed in grain feed production to measure the quality of grain, but less so in the areas that we are looking for. So there are new technologies in our area, but not necessarily new technologies, that are being developed specifically for this area. And in a recent study that Nicola led on, we found that so we looked at the use of visible near infrared in a large commercial processing plant to measure and test a system for meat quality, so intramuscular fat data collection. And VIS-NIR was applied at the freshly cut surface, in a commercial environment, in order to predict this laboratory measured intramuscular fat percentage. And the study produced results on the ability of VIS-NIR to predict intramuscular fat with moderate accuracy, so 40 to 50% accuracy, and then was validated across an independent data set with 54% accuracy. And the link to the papers on that slide if anyone's interested enough. So that's one of this. We're further developing with those partners, ABP and the Texas Sheep Society, implementing those visible to near infrared light gun systems in an abattoir environment. The next sort of piece of technology that's being developed, which is a step up, is hyperspectral imaging. So that's been at the moment. So that those images that I showed you at the meat lab was using hyperspectral imaging. So that this is a much more complex sort of system. It still uses the basic principles of light reflectance and absorbance, so it's just another spectral imaging technology. But rather than a single point, it's very, very dense. So here down at the bottom, you can see that it's a continual spectral. It's continual spectral information spatially and across every single pixel in the image. So it's a huge amount of data that it provides, which is quite frightening for people analysing the data. Not that I do that, but it provides an awful lot of data, and all that data is stored in a hypercube and analysed across every single pixel in the image. So you can either look at regions of interest, which is what we're doing down here, and then relate that back to all those other objective mechanical tenderness, objective measurements of meat quality. And it's being trialled at the moment, but very much in a lab environment. So it's very slow. It's a very expensive piece of kit. And in New Zealand, they've sort of developed kind of faster systems using hyperspectral imaging and near infrared that might be applied in commercial practices. So in summary, really, CT parameters can predict intramuscular fat with moderate accuracy. They weren't able to accurately predict mechanical tenderness or the sensory traits, but it's almost, for mechanical tenderness, it's almost a proxy trait, predicting a proxy trait. Near infrared parameters can predict intramuscular fat with moderate accuracy, but again, couldn't predict mechanical tenderness or the sensory traits. But we know that sensory traits are significantly influenced by intramuscular fat, so that's the texture, flavour, juiciness, and overall liking. And that juiciness and flavour through our previous studies has been shown to increase linearly with intramuscular fat. So as IMF increases, so does juiciness and flavour. And of course, we identified that optimal window, 4 to 5%, or certainly more than 3% for UK trained taste panel and intramuscular fat in lamb. So I'll just finish up, Kirsten, with the sort of main question I asked. I know the one about getting payments for quality, because there always is, but what is the value? Why is it important? I've said, meat quality is known to be linked to the fat levels. It's due to as positive as associations of intramuscular fat, but for the consumer, tenderness, juiciness, and flavour are the most important factors, and they're directly related with high eating quality for the consumer. And it can take up to 3 months for a consumer to repurchase red meat following a bad eating experience. And it was kind of coined best. This is a good few years ago now, because I've had this in previous presentations, where Neil Matthews, who's a geneticist like me, interested in meat quality like me, for PIC, so the Pig Improvement Group, coined it quite well. He said, you can be the best at efficient production, but if the consumer doesn't return again and again to purchase your product, you have a problem. And that's the sort of key takeaway there for meat quality and repeat purchase. So just left to thank or acknowledge the partners that were involved in most of those studies. And that's me.
Excellent. Thank you, Neil. There's 2 questions have come in that are very similar. I'm going to give you 1 minute and no more than 1 minute to answer it, and then we can maybe address it you can maybe put it in the chat, a bigger question, bigger answer. But with the possible UK-Australia trade deal at the moment, there's people that are wondering what your take is on the system that they're using for assessing eating quality on meat. So your thoughts there would be much appreciated.
Yeah, so the Australia and New Zealand are quite well advanced on, they use different methods like ossification, etc. And measuring meat quality. They also have a better sort of value-based marketing system in place for rewarding on meat eating quality. I think what are my thoughts on it? We work very closely with colleagues in Australia and New Zealand, so the application of and the research work that goes into a lot of these new technologies comes from, if you like, or is very often led by the Southern Hemisphere. Now the application or the implementation of them in rewarding producers for meat quality is less my area. Like I said, it always comes up as a question, and I think that's why I make the point about repeat purchase. There's definitely direct and indirect rewarding of meat quality. Direct's less my area, but indirect certainly still a reward.
Okay, thank you, Neil. We'll move on, very, very cautious of time. And next up, we have got Elodie Ruelle. Elodie has actually, she's a research officer with Teagasc over in Ireland with their grassland department, and she specialises in modelling biological systems, and she's in charge of the development and the maintenance of the most grass growth model. Elodie, I'll hand over to you.
Thank you. So yeah, hi everyone, my name is Elodie Ruelle. I work in Teagasc, Moor Park, so in Ireland, even though my accent probably does say something else, but yes, I'm working in Ireland. So I will talk to you today about grass and grass precision tools. So first of all, I guess the first question, you could ask is why grass? Why are we talking about grass? One of the easy answer we could give, and it's maybe obviously not the main, but still there's a very good consumer perception with grass. So they kind of love those kind of picture where you have animal grazing outside, cows, sheep, and so on. It does look nice, and consumer do like to have animals outdoor compared to when they are all the time or the full year indoor. But for the farmer, we'll say, and there's a lot of other reasons, but one of the good reasons for the farmer would actually be the cost and would actually be money. So a lot of study has been done in Ireland where if you compare the total cost of production of milk, so the more you put grass in the diet of the animal, the more your cost of production will reduce. So that's fairly positive. Data from Ireland again, so maybe it will be not as big on other country where grass doesn't grow as easily, but in Ireland anyway, the relative feed cost of grass is 1.9 times cheaper than grass silage and 2.9 points cheaper than concentrate. So once again, very positive. And final money story is that we did a good bit of study here, and it shows that every additional ton of grass eaten per hectare will increase your farm profit on beef farm by 105 euro per hectare and on dairy farm by 181 euro per hectare. So let's imagine if you have a farm with 40 hectares of grass or 100 hectares of grass, you do the multiplication, and that does look fairly nice, fairly fast. But however, everything I'm talking here is increasing grass intake. It's increasing grass intake per hectare, increasing grass in the diet of the animal. So it's not just putting the animal outside and suddenly you have more money. So to be able to get more advantage from grass, you need to be able to have a good management of that grass, and that's what we will talk there. And that's where precision and tools will have a big role for farmers. And you need to be able to be reactive, and that's where those tools will also help the farmer, because grass grows here. I'm showing you grass curve from Ireland from 2013 to 2020. So you can see you can have a good bit of variation by years, not 2 years. You can't know if this year will be the same than last year. So you need to be able to be reactive depending on your farm, and to be reactive depending on the year you're in. So if you look at the year like 2018, there was a big drought in the summer. Once again, big drought for Irish condition, but that was a very big problem here on that year. And actually it was a big problem also because the spring was fairly bad. So farmer had to feed a lot of silage during the spring, and there was no more stock of silage during the summer to fight that drought, we say. So the way my presentation will go is I will start to talk to you about mainly one grassland management tool, which is called pasture-based Ireland. Then I will move quickly on grass measuring tools. And then I will speak a bit about grass growth prediction, because that's what I know best. And that's in the topic. So grassland management tool, I'm going to speak about pasture-based Ireland. There's a good bit of other in the world, obviously. That's the one developed here. So pasture-based Ireland is a web-based grassland database developed by Teagasc in 2013. All the data entered in pasture-based are entered directly by the farmer, so it's really farmer-focused. And it's a grassland management tool and decision support tools. Currently, it's actually data from 2 years ago, so there's probably more now. There were 6,000 users, and if we want to be honest, there's 2,200 very active users. So it's people which should actually use weekly and enter data weekly into pasture-based Ireland. From those users, you have 90%, so mainly dairy farmer, 8% are beef farmer, and less than 2% are sheep farmer. But it's not only grass. In pasture-based Ireland, and that I think that's very important for tools which are like pasture-based Ireland, you try to have as many information as you can in one place, like that farmer don't have to go to 5 different apps to be able to take their decision for next week. So it's linked with weather station. We have some from Meteran, which is the weather body of Ireland. There's some installed by Teagasc also. So there's information about weather, about the milk also. So farmer can know what was their milk production of or milk quality for the previous week and so on. It's directly going into pasture-based Ireland. And there's also, which is very important for the grass, information about soil fertility. So it's linked to the lab, and you can have for each of their paddock of their farms, they can know if they did a soil test, obviously, what's the soil fertility of that paddock. And I will come back after on that, but that can be a big help. And also it's not only really for farmer, because the advisor, if the farmer agrees with GDPR, but if the farmer agrees, the advisor can have directly access of all the data the farmer is entering into pasture-based, all or part or whatever. So it can help advisor to directly have a picture of the farm and to know what's happening on the farm and to help them to give better advice faster and easier on what's going on into the farm. And then finally, it's also for us a massive database for research, because we actually have access to all those data. So it's very, very valuable when you have during the peak season, you may have 10,000 grass cover entry. So 10,000 farm entering data by week. Well, not 10,000, 5,000 farm entering data in 1 week, we'll say. So that's a lot of data for us that we can see really what's happening out there. So what are the tools now? So we'll say the main tools are tools for the short-term decision making. That one you can see there, it's what's called the grass wedge. So you may be very familiar with this, I don't know. I will explain quickly. Each bar you see, each green bar you see here corresponds to one paddock in the farm. The height of the bar corresponds to the biomass, so the amount of grass you actually have on that paddock. And the idea is the red line is your demand line, and you want as best as possible to have actually exactly what you have there, so that each bar will reach exactly your red line. So that's actually a perfect grass wedge. And that means that the farmer is managing well his grass and that he's well in time. If there was way more paddock like that, which would be way lower than the red line, that would mean they would be in grass deficit. So in that case, the farmer will have to take decision to not be in grass deficit. And if all those paddock were actually way higher than the red line, that would mean he has too much grass in his farm. That the highest paddock most of the time is the one which is going to be grazed next, and the lowest one is the one which just have been grazed. So on this, which is a landing page, well, as soon as the farmer logins, that's what he would see. So that's the main tool, but you can see also that there's other information. You have the growth, that's the grass growth for the previous week or for in between 2 and 3 of the farmer. So it does help him to know what's happening, what has happened anyway last week in his farm. And you have the grass demand per hectare. So you can compare the growth and the demand. You can see the farmer is actually growing more than what he needs. So he's flying it, he has way enough grass and so on. But at another time, he could be growing way less than what he needs, so then he may have to take decision. There's other information, so that's the grazing area, and more importantly there, so that the silage, that's the area of the farm which is waiting for silage cut, so that's the part that it's in grass but cannot be grazed at the minute. And so it's not present on the grass wedge. What are the tools that he can play with if if his grass wedge wasn't as perfect as that? Is very easily, he can very easily play with the system. And like, I know there's a lot of other management tools which would do exactly the same thing. Where if he had, we'll say, not enough grass on his farm, he could decrease the grass intake, so the amount of grass he wants to feed his cows, and increase the silage intake. If he was changing those numbers, then all would be recalculated and that would be adjusted, and he could see straight away if the decision he's taking would be actually good for his grass management. So that's a short-term decision making. That's a picture of his farm today, and like that he can take a decision or decide to take a decision or even test and see directly what would be the consequences for next week grass. There's other tool, I'm not gonna go into detail for short term, which could be the spring and autumn rotation planner, because you would manage your grass a bit differently during the spring and the autumn. But I think one of the very good tools that you could have with a management tool like pasture-based Ireland, if farmers are measuring their grass, is having some information for more the long term. So for example, here what you have is the cumulative yield, so the cumulative growth of all the paddock of a farm for 2020. In yellow, it's what has been cut for silage, and in green is what has been grazed. And what's very important here is you can see some paddock grew very well. They grew 16 ton, which is really a lot, but others grew less. Some grew 10 ton or some grew 6 ton. So the question here is why those paddock are growing way less than those one. And as you have the soil test directly into pasture base, you can go and you can check, okay, is the soil fertility of those paddock, which are growing less, good enough? If it's good, then you're gonna try to understand what's happening somewhere else. So maybe that paddock needs to be reseeded, or maybe it's just some soil which, I don't know, is way drier and there was a drought that year, so there's nothing you can do about it. Or the opposite, it was way too much rainfall and I don't know. You know, that does give you, at the end of the year, a very big picture of your farm and to know how each paddock performed and how you can improve each paddock individually, and to be able to identify which one you actually do need to improve. And for research, very quickly, so it's a national database. We have a lot of information on, at the end of the year, once again, you have the cumulative growth. So that was for each year, 2013, 14 to 19. Actually, I should have added 20, because what we could see is, so the dark blue is what has been grazed, and the light blue is what have been cut for silage. And you can see that 2018 was a lower grass growth. And after 2018, we have actually seen farmers starting to do a bigger percentage of silage compared to the year before, because there was such a fright in 2018 that people were starting to anticipate a bit more just in case another 2018 would happen. You have those graphs that I have shown already and that we can do live, so we can see lively each week if we are ahead or behind of grass growth compared to the other year in average for the country. And then you have information like this, which is available for anyone. You just go on pasture-based Ireland and you will be able to see that map, and which shows the average grass growth for the previous week for each of the Irish county. And well, there it's fairly uniform, but sometimes it's very good to be able to see that there's a drought happening in the eastern of the country and actually a lot of growth here, or the other way around. So that's fairly useful for research or for the industry to be able to see what's happening at big scale. But now what I think we need to always remember is asking the question, is it actually useful for the farmer? Because, you know, people are using it, it's good, but is it helping them? And it's always a question which I find is very, very hard to answer, but I will try anyway. So we have done, with the national survey, we have seen that the grass growth in average in Ireland is of 9.8 ton of dry matter per hectare. But if you look at people really using pasture-based Ireland, their grass growth for the 10 lower % is around 11 ton of dry matter per hectare, and the 10 top percent are around 60.7 ton of dry matter per hectare. So what does that mean is that your bottom 10 grower, doesn't mean the worst farmer, but the one which grows the less grass using pasture-based Ireland already grow more than your average Irish farmer. So that can mean two things. Either pasture-based diet help people to grow more and to manage their grass better, or people which manage their grass well and which grow more are more likely to use pasture-based Ireland. For me, it's a mix of two. People which don't like to manage their grass are not going to use a tool like pasture-based Ireland anyway. But now what we need to really look at, and what's very, very important, is grass measuring. So if you remember the wedge, all the information you had was the biomass on each paddock, and you can't know that if you're not measuring your grass, if you're not entering those data, if you're not going and see how much biomass you have in your paddocks, there is no point to try to use a tool like pasture-based Ireland because you won't be able to. And most of the Irish farmers don't really use very big technology to measure their grass. They would, at the start of the year, they would train their eye again and cut and weight the biomass on some of their paddock. And once they are trained again, they would actually just walk in their farm and visual assess the biomass on each of their paddock. So it worked very well. They're actually fairly accurate, but it's not very high tech, we'll say. But sometimes it's as good as tech. But then you have other tools which exist, which are the plate meter. So that's a very basic plate meter, but then you have some which are way more fancy. So I'm just going to present one, which is a grasshopper. The grasshopper is a plate meter, but which has a GPS including in it. So which means that at any time when the farmer would walk and use a plate meter in each of his paddock, a lot of time on each of his paddock, the grasshopper would know exactly in which paddock the farmer is, and the data will be transferred to be able to estimate the biomass on that paddock. It will go straight into his phone, and he won't have to enter any data manually. So that means that he just walks his farm, and then everything, boom, is in the app, and everything is ready for him. If he wants to also, and if you want to be very precise in his grass allocation, with the tool like the grasshopper, it could even tell him where to put the next fences exactly to give exactly the right allocation to his animal. One good thing for us again is that the grasshopper is directly linked with pasture-based Ireland. So if we have a farmer which wants to use the grasshopper, he can just walk his farm, and when he has finished to walk his farm, basically he can open pasture-based Ireland and his new grass wedge is done. And I think that's very important, once again, to have everything in the same place. That's a big help for the farmer. In the future, I guess there's more and more work around satellite estimation or radar estimation to try to estimate the biomass of paddock in farms. However, in Ireland anyway, for the moment, it's not working that well because there's a slight problem with satellite imagery and cloud cover because we have a very bad weather here. So it doesn't really work, it's not that ready yet. But I think in the future, there's more and more work going on, try to make no need for the farmer to actually go and walk his farm. I'm personally not a massive fan of it because I think it's very good when the farmer do go outside to be able to what's actually happened into his farm instead of just, having the data coming to him and not having to walk his farm. But at the same time, for farmer which would anyway just go once or even less than once a month, it's better. It would be better than what information he has at the minute. So, Now we're going to go into the next step, which is the grass growth prediction. And we're using the most grass growth model to predict grass growth. The most grass growth model has been developed here in Moorpark in conjunction with INRA in France. And I guess the first question, once again, is why grass growth prediction? Why do we care about how much grass is going to grow next week? Well, everything I've shown so far is a picture of the farm for today. It's what's happening today on the farm. It's how much grass you have today on your farm and so on. But let's say if you're starting to be in grass deficit, but actually next week, the grass growth is going to explode and there's going to be a lot of grass, there's no need to panic. Or the other way around, if okay, you're a bit tight, but you're still okay. But the grass growth actually next week is gonna go down for whatever reason, which could be a drought, which could be a cold weather or something. It's important to be able to know that, to be more precise in the management, in the decision you're gonna take. So grass growth, what do you need to be able to predict grass growth? And that's where things can get a bit tricky. So first of all, you need to be able to have weather information and weather forecast. And that's one of the big limitations, I guess. It's a bit the same in each country. We know that grass growth, forecast prediction, weather prediction are changing every day. Like, it's not very accurate. Okay, maybe it's okay for the next 3 days, but most of the time we try to do grass growth prediction for the next 7 days. So we know we will be okay for the first 3 days, and then it's a bit of luck, we'll say. But we do with what we have. Then you need other information to be able to predict grass growth on specific farm, which are the amount of nitrogen which have went out on each paddock, to be able to know, what's the state of the mineral nitrogen in the soil. And then you need also information about grass management. So when was the paddock grazed, cut, and so on. But luckily for us, once again, all those information are into pasture-based Ireland. So thanks to pasture-based Ireland and Meteran, which is sending us weather information, we have actually all the information we need to be able to do accurate and on-farm grass growth prediction. How those prediction looks, that was the one I did yesterday. So each small dot you see is one farm we're predicting grass growth on. We're currently, I think, predicting grass growth specifically on 57 Irish farm at the minute. We're trying to put them a bit everywhere in the country, but it's not always that easy. And all those farmers will be heavy user of pasture-based, because we know the data they are entering they are doing it often, and they are good data. And you can see there's big variability. You have that farm which is predicted to have a growth of 113. That farm is always growing a lot. And then you have other which are way lower with 49 there, which is probably always a bit colder weather, and he would be a farmer putting a bit less nitrogen and so on. So it's good information to have, we think. Now, the most important question is, what do the farmer think about it? So we did a survey. We should probably do another one at the end of 2019 about what the farmer were thinking about grass growth prediction. And they rated the usefulness of the model at 4 out of 5, and the model accuracy at 3.7 out of 5. So that's, we're fairly happy. But more importantly, 80% of the farmers involved in the study were changing their management due to the prediction we are sending weekly. So their change of management could be either just to reassure themselves, maybe they would have waited a bit more to cut that paddock for silage, but actually the grass growth model was saying that the growth would increase, so it gave them confidence on doing that. Or maybe they would have waited a bit more to feed silage, but actually the model is saying that, or to feed more concentrate, but the model is saying actually that grass growth is going to crash next week, so better start actually feeding now than waiting a bit more and being a bigger grass deficit next week. So, it worked well, and farmers are happy about it, and it is a good tool to be able to actually take decision on what's going to happen next and not on what has happened before. I guess one of my last point will be a bit about what's the future and the future of prediction. And I was just speaking about grass growth prediction there, but I think something we'll really have to go in is precision fertilizer application. For improving water quality and so on. So trying to have, and we're working on that really a lot right now. I'm going to hide that. So is there a point on putting fertilizer today if it's actually very cold, there's no growth predicted, and it's going to rain 60 millimeters of rain in the next 3 days? Obviously not. So we need to start to have tools to be able to help farmers to know a bit more when to apply fertilizer. And the other big fertilizer advice, which will be needed anyway in Ireland, is when you have a drought event, as small as it can be, do you need to put fertilizer after, or is it still enough nitrogen into your soil? And that's all linked to water quality, and that's all very important. In conclusion, I think there's huge scope to increase grass utilization, to increase sustainability in farm, in pasture-based system, And precision technology really have a very big role in all that, to be able to do more precision grazing, precision fertilizer timing, and so on. But I guess my final point, and I think it's the same in every sector, is that we need technology to answer a need. So for the farmer or for the industry or for government, I don't know, but not just develop technology because we can, and then farmer have it, they get data, but it's actually not useful. Thank you.
Brilliant. Thank you, Elodie. There's so many points in there. Really, really interesting. Thank you. I'm going to move swiftly on. There was a few questions there, but we'll move swiftly on to the next speakers. We have got Nicola, a bit of a double act. We've got Caroline and Nicola coming up next. Who's going first? Caroline, is it you? You're on mute. So Nicola and Caroline both work for SRUC, both researchers. Caroline is more on the beef side and Nicola is more on the sheep side. So Caroline, I'll hand over to you.
Thank you. Sorry, I lost my mute button, so I found it again. Can you see my slides there?
Yeah.
Yeah, so as Kirsten said, myself and Nicola are doing a bit of a double act. I'm based in our Beef and Sheep Research Centre and Nicola's based up in Hill Mountain Research Centre. So I'll talk about some of the developments we're doing in cattle specifically, and then I'll hand over to Nicola and she'll focus on some of the sheep work that we're doing, particularly around technology. So just picking up on Kirsten's point earlier, there's lots of different types of technologies out there available to us as farmers, but also in development. We've touched on EID and the benefits from EID and this transition towards ultra high frequency tagging for cattle farmers. There's systems out there that really are focused on monitoring productivity and not particularly complicated technology, quite simple technology that are now available to farmers. There's systems out there that really focus on imaging solutions, and that might have specific applications for monitoring of animal health or animal productivity. So I like this slide because it just gives a bit of an introduction on lots of different types of systems that are available out there now currently for farmers, and some of which that are under development. So I wasn't entirely sure how to frame this talk, but what I've done is I've selected two of the key projects that I'm working with, particularly in the cattle sector. One of them is focused very much on beef farmers and technologies that we can develop to support decision making on farm. And the other project is very much focused on calf breeding, so calves coming from the dairy sector. So I'll start with this OptiBeef project. So this is really a project that's got quite a lot of partners across the supply chain. It's led by Hallmark Veterinary Compliance Services. But you can see here a range of different partners, some of which are very much focused on technology. So Innovent Technology essentially develop imaging systems initially for the pig sector, but they've branched out and are now increasingly involved in imaging systems that we can apply in the cattle sector. These guys are working very closely with Ritchie in this project, and Ritchie have essentially commercialized previous products with us out of Innovate UK funded type work, but they're looking to essentially increase the number of technologies that they market that can help beef farmers essentially get data on farm to make that decision making process easier. We've also got the National Physics Laboratory, who are working with more novel sensing, and other players across the supply chain that are really interested in data from an informed management point of view. So we've got Harbro, who are interested from a nutritional management point of view, Hector, who are interested in data that we can generate on farm that can support that Sell My Livestock platform that Kirsten mentioned earlier as well, which is our online marketing platform for cattle and sheep. And we've also got and processors in here with Scott Beef. So essentially, the ambition of this project really is to develop a range of technologies that can be easily integrated. And the point is to try and generate that automated monitoring of performance and value on farm, all the way from calf all the way to carcass. We're also looking at technologies that can be linked in the abattoir that can improve on current grading systems. And the real benefit of this is trying to drive that optimized slaughter selection on farm to really meet that customer requirements. If we look at AHGV data, we're looking at, I think that the statistics now say roughly 50% of animals that meet the slaughterhouse are really not meeting those market specifications. And that has economic impacts both for the farmer and the processor, but also environmental impacts. So what we're trying to do here is is develop a range of technologies that farmers can access to give them that data, really to allow that decision making and improve that slaughter selection on farm. The real benefit here for me is integrating data on the individual animals that allows us to map or monitor that animal for its whole life, and decision making. I mean, Stevie mentioned earlier that the real benefit of data, and the purpose here isn't about the fancy technology. It's really about providing the information to farmers on that individual animal basis to really drive the efficiency improvements on farm and then support improvements across the beef supply chain. And I've put this diagram up because this really epitomizes what the project's about. You know, it's not about individual technologies, it's about integrating a range of technologies both on farm and in abattoir. So on the left-hand side of this diagram here, we've got a whole range of on-farm data. The benefit or the key ambition of what we're trying to achieve is technologies that are commercially viable for your beef farmer. We're looking at things like advanced 3D imaging on farm to allow us to map the individual carcass, novel fat sensing, technologies that can monitor both feed and water intake, and really the things that can be used from the point of weaning, so calf to carcass. And the benefit for me here is really linking that abattoir data and providing a much more detailed breakdown of that individual carcass. So yes, we can then start to monitor carcass development on farm and then feedback, you know, how that carcass is broken down in the abattoir at the point of grading to that farmer. And that gives a much more detailed breakdown of how that carcass has developed. The benefit here is integrating all the technology and all the information or data into a decision support tool that can really drive improvements across the supply chain or across that farm in terms of health and welfare, monitoring nutrition and managing that nutrition, monitoring individual animal health and its productivity. So just to give you an idea of the types of technology we're developing in this project. So at the top of the slide, you'll see some interesting technologies. Some of you might be already familiar with this beef monitor platform. It's an automatic weigh platform developed by Ritchie. As again, I mentioned, very simple technology. What you have at the front of this platform is an automatic, it's a water trough linked to EID. And Ritchie have now developed this system to accommodate both low frequency tagging and high frequency tagging, which makes it much more flexible for implementation on commercial farms, depending on how we go with the LF or UHF route in regulatory processes. And we've got just automatic load cells underneath this platform. So essentially, very simply, every time an animal accesses the platform, it takes a drink, it automatically logs the weight, links it to the EID tag of the animal and then to its UKID number, sends that information to a cloud-based server, and that information is all automated and available to the farmer. So we can monitor individual live weight performance of these animals reasonably easily on farm without that labour requirements of having to handle them and then that knock-on impacts of handling on productivity and performance. So this is quite a nice bit of technology that's already available to commercial farmers. What Ritchie have now done is they've essentially within this project looked at different prototype technologies. So the first one here is automatic feed intake recording. Part of the problem with monitoring individual animal feed intake on farm is actually that there's not solutions available to farmers that are commercially viable. So what they've taken is the learnings from their beef monitor platform and generated a first pass prototype of feed intake bins that can be integrated into the same data system as the live weight performance on farm. So we're testing this technology out at our Easter Howgate site. So this is one of our installations on our Easter Howgate farm just south of Edinburgh. And so we're essentially going to be refining this technology throughout the project and then installing them on some commercial farms for testing and demonstration. Additionally, they're also looking at monitoring of water intake, and this has benefits in terms of monitoring productivity, but also health. So essentially, this is the front end of a beef monitor platform, which gives us flexibility in integrating that into the beef monitor platform itself, or developing that as a standalone unit. So this in itself is a really nice suite, shall we say, of different technologies that we can easily integrate onto a commercial beef farm and then start to monitor that individual animal performance much more effectively. So what these guys are doing is Ritchie are working very closely now with Innovate Technology Limited and integrating their 3D camera systems onto the beef monitor platform. And essentially, we just mount a wee camera frame above this platform, and it's all nicely integrated with the Ritchie software. So essentially, every time an animal enters the platform, along with monitoring its live weight performance, we're also monitoring a 3D image of every animal. And by doing this, this allows us to start to extract different features from that image, and you can see an example here. And we're using that information to predict carcass value on farm. So we're now building that data set that can allow us to say, you know, what is the real economic value of that animal at that particular time, which should allow us to improve on that slaughter selection process. Now, if we look at the in-abattoir technologies, so on the top left here, this is essentially the same type of technology that Innovent has developed on farm. But essentially what we're doing is integrating that into two processors across the UK. Requires very little infrastructure. And essentially what we're now doing is building the data set in the abattoir that allows us to predict a few different features of that carcass and feed that back to the farm. So essentially, of course, we're focused on carcass weight and the current classifications. So Europe classifications for conformation and fat score. But we're going to take it just that step further forward. We want to know a bit more detailed information about the carcass. We want to know how much the meat yield comes off that carcass. But essentially, we also want to get down to these individual hindlimbs. Essentially, how long is the sirloin of that animal? How many steaks can we get from that animal, for example? So this is where we're heading with this in-abattoir technology. And on the top right here, this is some colleagues in the National Physics Laboratory. We're also looking at integrating novel sensing systems both on farm and in the abattoir so that we get a much more accurate picture of carcass fat yield. And this brings me back to this point that seems to keep coming through today, and it's about the data and where the value lies. It's not really in the technology. The technology is just a tool for us to gather that information, but the real value is in the data or the information rather that we generate from this technology and how we present that information to the farmer. So this is one of the big parts of this project is essentially developing a range of data for platforms that can be easily integrated and easily presented to the farmer. And these are just some examples. On the left here, this is a Ritchie system. We've got lots of individual animals and a very simple traffic light system that says, these animals in red are really not performing particularly well. They're not meeting your targets in terms of live weight gain. But the ones in green are doing exceptionally well. You know, they're meeting and exceeding what you expected in terms of live weight gains. So that's really useful in terms of management. And this is just an example on the right-hand side here. If you haven't seen this Sell My Livestock platform, I recommend you go and have a look at it. What they're trying to do within this project is increase the amount of data by linking with these types of technology on farm so that we get a much better breakdown or picture of animals that are being sold on that platform. So the key capabilities of this type of project really is around optimizing efficiency. What we want to do is monitor the key aspects of performance and carcass value on farm. We're really driving towards that consistency in meeting that abattoir specification. So meeting what the consumer wants or what the processor wants. And that has a win-win scenario in terms of optimum price for the farmer and reducing the price penalties. But also in terms of greenhouse gas output. So if we're optimizing efficiency on farm, finishing those animals sooner, we really do have a knock-on benefit in terms of the carbon footprint of that farm. So we're looking to finish animals sooner, more effectively, which of course reduces the cost of production, so reduces our feed, our bedding and our labour, but also allows us to identify individual animal health issues that do manifest themselves through poor performance. So this data has much more inherent benefits than just being able to select individuals for slaughter at the right time, but it allows us to monitor the performance of that animal. You know, we're looking at feeding behaviours, we're looking at water intake, we're looking at live weight performance. So that allows us to monitor individual animal health much more effectively as well. And as I said, improving abattoir carcass evaluation and product consistency. So there's lots of benefits of this type of data and information that we can generate on farm. So I'm going to move now on to a slightly different project that I'm involved in, which is called Well Calf. Now, Well Calf really is driven by this issue in the dairy sector where we have significant antibiotic use and huge amounts of respiratory disease in this type of system. So calves are in the pre-weaning phase, often have lots of issues with scours, respiratory disease, and then subsequent antibiotic use. So the aim of this well calf project, and again, you can see some players, these are the key partners involved in this project. We've got Smart Bell, which is our technology provider, Parkland's veterinary group, who are really interested in the data that we can generate on farm to drive improvements in the management of these calves, ourselves as academic lead in Agri Epicenter. So essentially what we're trying to do with this project is integrate both sensor and on-farm data to improve the profitability and growth rates of these calves, reduce our antimicrobial usage, improve on-farm data-driven decisions as this data keeps coming through, but also improve metrics of welfare and animal health. If we look at some key statistics, and this is just some key points that I've pulled out for the purpose of this, is that if we look at the range of farms in the UK, the top 10% of farms have got double the calf growth rate and only 1/3 of the antibiotic use compared to the bottom 10%. So there's huge variation in this sector. And the key contributors to this really are pneumonia, and the cost of pneumonia to the UK industry really is quite significant. And we're looking at about 80 million per annum, and that's a significant cost. And if you look at the cost of scours, it costs the UK industry over 40 million per annum. And the biggest issue in management of these calves is that there's not actually a solution, a commercial solution that's currently available for younger calves. A lot of the technology development today really has focused on your adult cows, so management of, for example, fertility in the adult cow, but much less attention has been paid to our younger calves. And it's really important to get that right in this phase of their life, because that has knock-on effects on lifetime productivity and lifetime performance. So we really need to be improving our management of our young stock.
It all starts with the animal's potential, but it takes the right environment.
Excuse me. So this diagram here really kind of describes what we're trying to achieve with this project. So what we're trying to do is integrate information about health, information about the animal's environment, and information about its nutrition and its performance. So we're looking at developing sensor systems that monitor aspects of behavioral change, which tells us about individual animal health in the context of its environment and its productivity. So this work's being done at the minute down at our calf facility at Crichton. And this is just an example here, a diagram here on the left-hand side. So this is Isla presenting our calf facility. We've recently invested in a lot of technology on our facility, where we are now able to monitor important aspects of the animal to underpin those type of technology developments. So we monitor everything from individual animal feed intake to individual animal performance. But we also have now recently invested in bucket feeding systems. And the benefit of this for us when we're developing this type of technology is to make sure that what we develop isn't specific to Crichton, specific to our research facility, but can also be implemented on a system like a bucket feeding system. Essentially, this has gone through rounds and rounds and rounds of prototype testing, lots of different calf tag shapes. These are the sort of types of examples, different sizes, different weights, different shapes, to try and get to something that we're comfortable with in terms of calf comfort, calf welfare, optimized battery life, and performance of the data transfer of this tag. And this on the bottom left here is essentially the final commercial product that these guys have got to. So this is now robust, it's weatherproof, it's reasonably easy to set up, and has a reasonable long lifetime. Certainly something that's required when developing these types of sensor systems. And the key thing that we've been focused on in testing all these prototypes is that it's really comfortable for the calf and safe for the calf. And when we're looking at this type of sensor system, we really need to think about what is the gold standard in terms of monitoring calf health or calf disease. And we've been using this scoring system down at Crichton for a number of years, and this is called the Wisconsin scoring system. And this allows us to accurately determine when a calf suffers ill health, because quite often, if we rely solely on stockman identified health, there's some discrepancy. So sometimes stockmen are not being able to identify those subclinical cases of disease, things that don't present themselves that easily. And sometimes animals are being treated when they don't necessarily need to be treated. So this is the best and I suggest probably one of the internationally recognized systems of monitoring calf health. We look at things like rectal temperature, cough, nasal discharge, eye, ear, and fecal scores. And this allows us to build up a nice picture of calf health throughout its pre-weaning phase. But it's a huge amount of effort to capture that type of data every single day from every single calf. And we've been building up a data set at Crichton, which is reasonably extensive, I have to say, where we're combining information about the animal's performance with information about animal health and animal treatments, and all of that underpinning data on feed intake, feed performance and activity that allows us to develop this sensor system for an individual calf. So you can imagine this is a huge amount of effort from our technician team at Crichton. That has allowed us to develop this sensor system that's on, we're almost there, we're getting towards the end of the project. So essentially it's been the first, I guess, calf feeding system purpose-built for young stock, being tested both on our research facility, but now engaging with commercial leaders across the UK. I think we've now got 14 farms set up as part of this project and more extensive projects. It's already as good as the stock we're at Kirsten at detecting scour, but actually 80% better when we're looking at respiratory disease, which is much harder to see. So what essentially these guys do, and this is just an example trace here from one of the calves in the study. Alerts are triggered by an index which combines the animal's behavior, activity, temperature, and environment, and can often generate a warning as much as 2 days before it was treated, so 2 days before it was identified by a stock count. And that offers inherent benefits in how we manage those calves, how we treat those calves, and manage them within the group. So the next steps in this project really is to start to look at the impact of subclinical cases of disease and what we can identify in terms of management of those calves, and then quantify the improvements in managing that young stock health much more effectively across the lifetime performance of that calf. And I just wanted to pick up on a last slide here, which is how we're engaging with commercial farmers in this project. You know, we have, I guess, imposed a very simple technology. Most of you will be really familiar with WhatsApp. So we're working very closely with these commercial farmers to start to understand how well the alerting systems are working on farm, how the farmers are engaging with the process and engaging with the technology. You know, allowing us to pick up pneumonia effectively, whether it's identifying other sickness events, because essentially what we're monitoring is an animal's behavior and how that animal's behavior changes. And those anomalies or differences in behavior from what we expect to be normal for that calf may well pick up other sickness events that's not necessarily respiratory disease or scour. And also, events in the farm itself has an impact obviously on animal behavior. So we're often setting a series of flags on events, for example, like days where we're dehorning calves. So we're working very closely with these range of 14 farms across the UK to really start to understand the benefits of the technology to them and how well it's performing on commercial farms. So I think I'm going to hand over now to Nicola to talk about some of the sheep developments.
Okay, so I'm just going to talk about a few new technologies in sheep farming. So not all of this work's my own, so I've listed all the others that have given me slides or information for this as well. So as Kirsten mentioned earlier, EID being compulsory for sheep in the UK has had quite a big impact on the amount of data that we can collect on farm, and has been used as a benefit in a lot of farms to set up more of a precision livestock farming type of approach. So this is collecting information on individual animals and using that to inform our decision making. So just an example from our SRUC sheep farm. So this picture here is our kit at the Hill and Mountain Research Centre at Kirkton. So this is just a weigh crate, but it's EID enabled and it has an automatic 5-way shedder at the front. And so this is paired with the weigh head that you see at the top there. And we can upload and download a lot of information off that weigh head and use it in our management practices. So we use it for things like recording movements and medicines, but also for some of our different tasks that we do throughout the year. So for our finishing lambs, for example, we finish our lambs on the project, the long-term breeding project, and sell the males directly to the abattoir. So we can monitor their growth rates over time very effectively and weigh them every week or two very quickly using this setup and shed them into to different groups based on their growth rates and their final weights. We also use it at different times during the year for group management, or to put sheep into different groups. So for example, we use single sire mating groups at tupping, and we can use this system to upload the information to what ewe has to go into which group, and to sort them into these groups very quickly, using a lot less people than we used to do when we did it all manually. And then at pregnancy scanning, we use it to sort the ewes into their groups depending on the number of lambs that they're carrying. And then we also use it through winter for sorting ewes into feeding groups. So we use the weight change facility on the wayhead. We've got the information on the animals loaded into wayhead, and it can tell us how much weight they've put on or lost since the last weighing session. And we use that to automatically then allocate the ewes into feeding groups based on how close they are to their target weight at different times during the winter. And we also use it for some of our worming decisions for lambs during the summer, and I'll explain this a bit more in the next slides. So it's played a big part in our applied research, but a lot of the things that we do with it are things that could be done on a commercial farm if they had this technology. Just to look a bit more at this targeted worming, this is work that we've done in collaboration with the More Done, and the theory is that we only want to dose lambs that aren't thriving. So it's better for the animals themselves, and it dilutes resistance to anthelmintics. So we compare the weights of the lambs every time we weigh them throughout the summer to a target weight that's been created by an algorithm, and it's a target weight for that individual lamb. So it uses the information from previous weights and from the biomass in the fields that they're grazing. Compare the target weight with the actual weight of the lamb at each weighing session, and we only dose the animals that don't meet their target weight. To assess whether this was working, we kept a group of lambs as a control group, so they were wormed just based on pooled fecal egg counts to the weight of the heaviest lamb in the group. Whereas with our targeted approach using our weigh crate and our precision livestock farming, we're dosing to much smaller groups of weight. So we're dosing to the animal's actual weight or very close to it. And so this was some results from 3 years of the targeted selective worming treatment. And this was done by my colleague Claire Morgan Davis. So she compared the lamb weights of those that have been dosed on the precision livestock farming regime compared to the conventional regime. So this is the left-hand graph here. And you can see the average weights of the lambs are very similar at each point throughout the summer. So it wasn't affecting lamb growth using this worming strategy. But the graph on the right here shows that we used a lot less wormer over the 3 years using the targeted selective treatment, or the PLF approach, compared to the control. And this has now been taken forward by a project that Claire is leading in, again with More Done, called Smart Sheep. And this is now incorporating this targeted selective treatment algorithm onto a wayhead for use in commercial farms. So it's really taking it to the next stage for commercial application. Another technology that we are bringing into some of our research projects with the aim of trialing them for commercial application is using a walkover weigher. So again, it's just a weigh platform, just looking at live weights over time, but ways that we can collect this information more automatically in the field, and particularly when sheep are grazing, which is much more relevant for a lot of the production systems in the UK. These are some pictures from France and from two of the partners in EU projects that we have just started. So one of them is the Tech Care project. It's using technology to improve sheep welfare. And another project, SMART, is looking at small ruminant technologies for different applications. In this picture here, they're using a water trough to entice the sheep to walk over the weigh platform. So it's completely unmanned, and the weigh platforms are just in the middle of the field, but you have to get traffic across the weigh platform to collect the data. So if there's usually some attraction at the other side of the platform. So it might be a water trough, it might be a food source, or it might be a fresh area of grazing. Then you can use that to attract the animals across the way platform. But the information on the live weights is collected automatically and uploaded. And a lot of what we've spoken about in the different talks today is linked to this Internet of Things. So different issues in terms of smart farming technologies that we can use on farm. And a lot of this is taking packets of data and uploading them either through the mobile phone networks or the internet. But in a lot of the rural and upland areas in Scotland and the UK, there's very poor phone signals, or internet connections can be unreliable. And some of these technologies also need line of sight. So for example, drones, you're meant to have line of sight when you're flying them anytime, and that's quite difficult in some of these farming situations. And also, as Malcolm mentioned before, battery life can be an issue for some of these technologies as well. So at our Hill and Mountain Research Centre, we are looking at a LoRaWAN network. So we've set one up on at Kirsten Farm and our Hill and Mountain Research Centre. And this type of network is slightly different. It's long range, low power network. It's relatively low cost. And in rural areas, you typically get over 10 miles range from the gateway. So it's ideal really for deployment of sensors and devices where you want to transfer small packets of data periodically. And the Scottish Government's committed to rolling out these LoRaWAN networks throughout the country. So this is a potential area where we might be able to tap into with some of the technologies that we've mentioned today. So just one example of how we've been using it at Kirsten. We've got collars on ewes and lambs in the fields at the moment. And on the lambs, these are just small beacons that are on collars around their neck. And in the ewes, it's slightly larger receivers. And the interactions between the different animals are recorded on the beacons around the ewe's neck. And they then transmit this data up to the gateway every 5 minutes. And this gives information on likely relationships. So you can look at how often or how closely the animals are interacting with each other. And the ewe collars that we're testing this year, they also have GPS capabilities. So we can look at things like lambing behavior and lambing location sites and try to incorporate that data and see how much information we can get from these types of technologies. Again, this is something that's been used in the Tech Care project, looking at technologies for improving sheep welfare. So this is the sort of data that we might get. We can look at the signal strength between the different beacons and receivers, and we can see how close each lamb stayed from each ewe. And that way we can try and estimate which ewes are related to which lambs. And so this can give us information on potential pedigree information, as well as some behavioural data. And when we're talking about technology, I can never not mention CT scanning. So this is another technology that SRUC has been involved with for over 20 years now. And the main reason that we use CT scanning is to look at carcass traits, so to estimate the amount of total muscle and fat in the carcass. And as Neil mentioned, we can scan live sheep and look at these traits in the live animal, and this can be used in the national breeding programs. So as part of the national terminal sire breeding programs, we've been scanning commercial ram lambs since the late 1990s. So we have records on over 12,000 ram lambs from commercial farms to date, and we're looking at traits like total muscle, total fat, and muscularity. But our decision feeding into this to increase the number of traits that we can measure from CT scanning. So a couple of years ago, these new traits came on board with Cygnet and AHDB to provide the performance recorded flocks that were getting estimated breeding values with new traits that we can record from the CT scanning images that are collected. So as well as the carcass composition traits, we're also now producing EBVs on number of vertebrae in the different regions of the spine, so the thoracic and the lumbar regions where we get the high priced cuts of meat from, and also the length of these different spinal regions. And we're looking at muscularity in the loin, so looking at eye muscle area as well as the leg muscularity that we had previously. And as Neil mentioned, we also now produce a breeding value for intramuscular fat prediction using the density information that's collected from CT scanning. And then moving on, we want to try and add value to CT scanning by measuring more traits. So once the animal's been scanned, we have the archive images from these sheep that we can then go back and measure additional traits from. So one of the traits we've been looking at recently with our Scottish Government funded work is lambing ease predictors. And it's all ram lambs that we measure, as I mentioned. So ideally we want something we can measure in these sires that can predict lambing ease in their daughters or of their progeny. So we're measuring things like shoulder width, hip width, pelvic dimensions and pelvic angle. And so far we've found that there are breed differences in these different measurements when we look between the different terminal sire breeds. And even within breed, there's genetic variation, and it is, they are heritable traits and they're genetically linked to lambing ease. So it's something that could be used potentially for selection for lambing ease in the future. Another thing that there's a lot of interest in from the Scottish Government and from other areas is predicting methane. So we know from previous research that rumen volume, or the volume of the reticulum and the rumen together, can give good indication of the amount of methane individual animals produce. And so we've gone back to our CT archives and measured rumen volumes from different breeds that we've scanned in the past, and we've found breed differences at the same live weight. And even within breed, again, we've found that there's genetic variation. So as a heritable trait that we could potentially breed from to make differences in methane emissions from individual sheep. Just linked to that, the last couple of things I want to mention are feed intake recording and methane emission recording directly. So these are two things that we've been concentrating on in an EU project called Teagasc with various different international partners. Again, this feed intake recording kit or equipment uses the EID technology in the ear tags in the sheep to tell us which animals are feeding at what time and how much they're eating. So the bins that you can see here have they have weigh scales so they can tell how much feed's in the bin, and they can tell how long each animal's eating for and how much they eat in each meal, which gives us very detailed information on individual feed intake. And we can potentially use that for future breeding or to understand relationships with other traits. And one of the traits we're particularly interested in is methane emissions. And there are ways of measuring that directly in sheep. One of them is to use methane chambers and keep the animals in there for a few days. But these portable accumulation chambers are a way of doing that much more quickly. So these are small boxes that animals can go into for less than an hour, and you get very accurate information on methane emissions, and that can be from grazing animals as well. So this is being used now in a number of different countries around the world. So these are some of the partners in the Teagasc project. And in New Zealand and Ireland, they're actually taking some of these measurements and feeding them into their breeding programs. And in New Zealand, they're taking these portable chambers round on trailers to commercial breeding farms to measure methane emissions from individual sheep to feed into their breeding programs. And at SRUC, we have just got funding for some of these chambers, which will be arriving later this year or early next year. So just quickly to summarise from both the beef and sheep side of things, again, we come back to the fact that collection of accurate data is vital, both at the farm, field and individual level. It can inform our management decisions and help we make targeted interventions, and also inform breeding decisions to genetically improve some of these traits. Some of the technologies that Caroline and I have mentioned can reduce labour requirements, costs, low drug resistance, improve efficiency, health and welfare, and increase rates of genetic improvement. And these technologies are evolving really quickly. They're becoming more user-friendly and becoming more affordable. And I know that's been a bit of a barrier that's been mentioned throughout the talks today. But hopefully another positive is that these new technologies may be attracting a new generation of beef and sheep farmers into the industry. So I think that was all I wanted to say, and just to acknowledge the funders of the studies that I've talked about.
Super, thank you so much to both to both of you. So many exciting projects there. That last one you're speaking about, the chambers being used commercially, that's really, really exciting. We're quite off of time. We've got one final speaker who's a really, really short segment. So I'm going to introduce Jenna Bowen. Jenna, if you want to share your screen just while I introduce you. So Jenna, and I promise this will be a short, there's hardly any slides here, but Jenna is hugely focused on improving ruminant production systems using agri-tech. So over to you, Jenna.
Great, thanks, Kirsten. Just want to check you can see my screen okay?
Yes.
Perfect, thanks. So this was a think tank project that was in collaboration with Morden Research Institute and the Centre, who acted as kind of main stakeholder within this project. And this project was aimed to identify research priorities for agri-tech use to improve things like productivity, efficiency, and ultimately sustainability within beef and sheep production systems in Scotland. So agri-tech in beef and sheep production systems is currently low in comparison to uptake in dairy systems. And as I said, the aims of this were to effectively identify limitations, barriers to uptake, but also research priority areas for where we can use agri-tech. So we've seen in previous kind of presentations this afternoon that agri-tech and data can really help improve things like animal health and welfare, productivity and efficiency. But this project was also aimed at kind of essentially what should come next and kind of what are the barriers and how do we overcome them. So this was achieved through the use of an online survey and then a follow-up virtual workshop. So the survey was circulated to a range of stakeholders, including farmers, crofters, consultants, advisors, vets. So essentially people who use or would use these systems on kind of a regular basis. So the survey itself was split into 4 different sections, including basic information on, say, geographic location, age, type of enterprise, whether that be beef or sheep or a combination. But then followed on to questions more specific for agri-tech. So do you currently use agri-tech? What are the limitations and barriers to uptake? And what are the research priorities? And a virtual workshop was then held after that to further discuss the kind of views that were shown in the survey. So the majority of respondents were from within Scotland and include a mix of farmers, vets and consultants and advisors, which is what we were aiming for. So as I said, one of the sections of the survey was identifying current agri-tech use. So technologies associated with live weight and growth had the largest number of responses from beef enterprises, you can see in the figure on the left, followed by calving, electronic animal identification or EID, animal health, nutrition, fertility and estrus, and then rumination. And similarly, technologies associated with EID had the largest number of responses in the sheep sector, so the figure on the right, followed then by live weight and growth, animal health, reproduction and lambing, nutrition and location. Though just to note as well, the information on, say, the types of diseases or animal ill health used or detected using agritech wasn't collected in this survey. So the next section of the survey was about, say, limitations of the systems and barriers to uptake. And the main limitation identified was, not unsurprisingly, the cost. So this was identified in 32 respondents from beef and 33 from the sheep sector. However, this is possibly due to a lack of understanding on, say, return on investments, or not seeing kind of instant bang for your buck by investing in these systems. Other limitations included the need for systems to connect to the internet, particularly issues in regions with unreliable internet connection or kind of insufficient coverage, which again we mentioned in kind of previous presentations too. So there was also limitations around insufficient training or not knowing how to fully use the system or understanding, say, the full functionality of it. And also not understanding the benefits. So respondents were then asked to rank on a scale of 1 to 7 for beef and 1 to 6 for sheep, which research area should be prioritised. So 1 being the most important and 6 being the least. So you can see on these kind of two graphs that we have here, the darkest colours, these represent the most important, so areas that were ranked as number 1. And then moving up the colours towards the lightest colours, so the lightest ones would have been the least important, so ranked as either 6 or 7. So if we take the top 3 kind of positive responses and then kind of set a threshold, this is what each of these red lines represent, we can get an idea of research priority areas. So essentially, the higher up the red line on the graph, the greater number of positive responses. So within the beef sector on the figure on the left, animal health, live weight and growth, fertility and estrus, and nutrition were identified as being priority areas. Similarly, within sheep on the figure on the right, animal health was identified as the top, followed by live weight and growth, EID use for management, and also nutrition. But as I said previously, we didn't actually delve into the kind of actual health issues or diseases associated with the kind of animal health category. So we then conducted a follow-on workshop to effectively further discuss the views expressed kind of in the survey. So the workshop was focused on 3 main areas or points of discussion, which were the positives and negatives to current systems, barriers to uptake and what the potential solutions for them might look like, and also what technologies would you like to see going forward. So this slide is just a few of the main points discussed and outcomes of the workshop. So uptake of technology is on a spectrum, with some farmers having high uptake and others having little to no uptake. So it was discussed that there needs to be a kind of stepped approach to encourage uptake across the board. So even low level kind of easy access technologies would still lead to overall gains and improved management decisions. Knowledge and confidence in using these systems is low, but there is this potentially links to the kind of not knowing the full benefits of the system or how the systems fully work. It was discussed that the sheep industry could make more use of EID for management, as potentially missing opportunities to capture and use data for management, and again, kind of improve efficiencies. So this is also something that's kind of becoming more relevant to beef farmers with the introduction of compulsory EID tagging in the near future. It was also noted that data needs to be fed back down the supply chain. So for example, there's currently little to no feedback to breeders on a finishing animal's performance. And in my opinion, one of the kind of really interesting comments or points that came out of the discussion was around the use of data. So in that the data or the quantity of the data being used, being produced for multiple data streams or multiple systems is just too much. And it was suggested that user-friendly apps, which display just the key messages, are required to help drive, say, improvements on farm. So not all data is important for a farmer's decision making. I think that one of the participants put it in a kind of really neat and well summed up way. In the farmers want to spend more time driving their tractors and less time driving their computers. So there's a clear need for integration of these kind of systems and data streams. So just to quickly sum up then, that was just a really brief kind of overview of this Safari funded think tank. And if anyone's interested, the final report will be available on the Safari website at some point shortly. So.
Super. Thank you very much, Jenna.
So thanks.
We are so far out of time. My aim of let's finish at 3:30 is completely and utterly blown out the water. So I think we'll, rather than go to questions, our speakers have been trying to answer questions as we've gone. So I think we'll maybe just leave the questions and just kind of sum up. And I think this quote maybe just sums it up quite nicely. You can have data without information, but you cannot have information without data. So I think that sums up. We keep coming back to data, how important it is. We're looking at changing markets, changing policy, and with those both changing, unfortunately, our behaviours have to change as well, and that data is going to become something very, very important. I'd just like to thank our funder for today, the University Innovation Fund. I'd also like to thank the speakers and to everybody who's come along today. We've had a really huge amount of people come, and I'm really, really surprised given the weather that we've got. This has been recorded, and we'll send round the recording to everybody that's registered. And if there's any further questions that you've not managed to get or haven't got addressed, if you can just email them through to me, and my email address is on the screen there. But thank you once again to speakers and to everybody joining, and go and get an ice cream and enjoy the sunny afternoon. Thank you.